All right, on the last problem on the other page, I thought I had a typo with the directions, but I can see we're just continuing to use the same figure. I think I just copied the figure over for each problem so you didn't have to go back and erase and get confused with our markings. Okay, so now we want to know, is triangle TVS congruent to triangle TVU? So let's just make sure we understand TVS is this whole triangle. Is that congruent to TVU? So we have to filter out some of the stuff on the inside, like for example, we're going to ignore this line and we're going to ignore that line. And this might feel like cheating a little bit, but I'm able to actually get rid of those for you guys so we can filter that out. I mean, it's not cheating. This is what you want to mentally do in your brain, is just say, okay, that's not the triangle we're looking at. So just to make it very clear, are these two triangles congruent? So what do we know about these two triangles? Well, we've got our right angle with this straight line, so linear pair. If that's a right angle, that's a right angle. I can see that we have a side congruent to a side. We have two right angles, so we have a congruent angle. And then we have this shared side in the middle. So TV is congruent to TV. So now we have two sides in the included angle. So yeah, these two triangles are congruent by side, angle, side. Is that what we did in our last one too? Well, all right. All right, so number 24, is triangle TWS congruent to triangle TWU? Explain that. So let's just make sure we're seeing the triangles correctly. TWS, is this congruent to TWU? So in order to answer this question, we're going to refer back to what, I think maybe just the last problem, what we did. So do you see how in this last problem we said that these two big triangles were congruent? So once we've established these are congruent, that means that all the corresponding parts are also congruent. So do we see any angles or sides in these triangles that were also part of these down here? So the first one I notice is ST. All right, ST is part of this triangle I'm trying to prove congruent down here also. So because these triangles are congruent, that means that from up here, we know that ST and UT are congruent. So I'm going to go ahead and mark ST is congruent to UT. We'll actually write this one out. ST is congruent to UT, and those are congruent by, it's the corresponding parts of congruent triangles are congruent. So because we already showed that these triangles are congruent, all the corresponding parts are congruent between these two triangles. And if we're using any of those same corresponding parts down here, then we already know that they're congruent because we found these triangles to be congruent. So this is that CPCTC. All right, another part that is the same between the two is this angle right here. Do you guys see this angle at T is the same as this angle at T, and this angle at T is the same as this angle at T? So we know that up here, these angles were congruent because we knew the triangles were congruent, so the corresponding parts are congruent. So down here, those angles are still congruent. So angle STW is congruent to angle UTW. And again, that's by CPCTC again. Because we established the triangle is congruent up here, all the corresponding parts are congruent and some of those same parts are being used. All right, last thing is this TW. Do you guys see how TW is a shared side? So that means TW is congruent to itself. So now, are these two triangles congruent that I have highlighted down here? We have two sides. Where our two sides meet is this angle, because that is marked congruent. That is an included angle. So this is side, angle, side. All right, so number 25, find the perimeter and quadrilateral of ABCD. Well, let's just make sure we recognize ABCD is a quadrilateral, so four sides. So A, B, C, D, and all the way back to A. So that's what we're trying to figure out. What I notice is we have two smaller triangles that are making up that quadrilateral. So if we look at our two smaller triangles and identify what types of triangles they are, that might help us to find all the sides we need to find the perimeter. Perimeter is adding up our four sides. So this triangle here on the left side, we have two congruency marks making this an isosceles triangle. Isosceles triangle has two congruent sides. We know that AB is 11, so that makes BD also 11. Then I notice that over here, this triangle has 1, 2, 3 congruent sides. Equilateral triangles have 3 congruent sides, and we just figured out that this one was 11, which means this side is 11 and this side is 11. And what we just did is got the four sides that we need to add together to get our perimeter. So the perimeter is going to be equal to 11 plus 11 plus 11 plus 8. So 11, 11, and 11 give us 33, and 33 plus 8 is 41.